Right, so once we've done our lithography and validated it, we'll then pass it into another process, in this case etching. So what is etching? In layman's terms, it's removing of parts of the substrate. There are two main types of etching. We can have dry etching, which is done usually with plasma chemistry, or we can use wet chemical etching. Now with dry etching, we can achieve nice straight sidewalls like you might want for a waveguide. With chemical etching, it etches in all directions, so it's what's called isotropic, which obviously doesn't work well for forming waveguides, but it's very good. It can be extremely selective to certain materials, so it's good for things like stripping resist or removing the entirety of certain layers. Now, even within a dry etch process, we can have elements of chemical etching and elements of physical etching. So that the chemical etching will be isotropic, as the diagram on the left shows, so it will cause an undercut and etch in all directions, but the physical etching will be more directional, so it will help us to form sort of rectangular or square structures. And in a dry plasma process, we would have a combination of the both to try to achieve whatever our targets are. I think I'm going to skip over this because I am going to be short on time, but the left hand side shows what a plasma chamber might look like. If you want to watch this back on YouTube, you can pause it and read the text. It explains how a plasma is formed in the chamber. The idea of the plasma is it breaks down the gases that you input and it forms very reactive neutral elements plus some ions that can be accelerated towards the substrate, and that causes the physical etching. The very reactive neutral elements are what cause the chemical etching. Now the ions are accelerated towards the substrate because when the plasma forms, the very light electrons that are alternating in this electric field that's applied to the chamber to create the plasma, these electrons accumulate on the stage, forming a negative bias that then accelerates the positively charged ions in the plasma towards the substrate and causes an etching here. But it's important to consider that we also etch away the mask, so we need to have a mask layer that's thick enough or a process that's selective enough to what we want to etch to make sure that we don't run out of resist during the etching process. And this table just sort of summarizes what might etch different things. I picked silicon dioxide and resist since they're very commonly used in silicon photonics. The top three lines are all dry etch processes. You'll notice we can use argon, which is an inert gas, so that's pretty much just a physical etching process. So it'll etch anything in its way. Or we can use different gases. Just to point out, oxygen plasma is very selective to photoresist, so we use that to typically strip the resist once we've finished etching. And the bottom three rows show different chemicals that are very selective to certain things. So hydrofluoric acid is very commonly used to etch away silicon dioxide.